everyone, I am Emily Smail, and I am here today to talk to you about the coastal eutrophication activities in CS Coast. Eutrophication is a process where you get nutrient inputs that cause algal growth, and this can lead to a lot of detrimental impacts to the environment. So you can get light reduction, which can cause problems for ecosystems such as coral reefs or seagrasses, as well as growth of bacteria that can cause hypoxia events that can lead to fish die-offs or other problems. And a lot of the ways that these are measured are through direct measurements, so in water activities where you are measuring the nutrients, as well as indirect measurements where you are looking at chlorophyll A, which is a pigment in algae, which can give you a proxy of algal growth that could potentially be related to eutrophication, as well as water transparency, dissolved oxygen, and trophic level. What we have been doing for GEO and CEOS so far is primarily focused on the chlorophyll A aspect, so looking at the algal growth that would be related to eutrophication. Down the line, we are interested in adding in other components, such as looking at land use changes, which could be related to agriculture. So as we talked about earlier, some of the agriculture can be driving the eutrophication process through the inputs of nutrients. But we're going to talk today primarily about the eutrophication monitoring, looking at satellite-derived chlorophyll. So the United Nations Environment Program is the custodian agency for a Sustainable Development Goal indicator on coastal eutrophication. And for this indicator, the method that has been developed is broken down into different levels. So global, national, regional, and then supplementary, which would be additional indicators such as some of the land use change and other supplementary information. From the GEO side, we have been helping out the United Nations Environment Program by working to pull in some global data products, which can track global trends in chlorophyll A, so looking at deviations and anomalies in chlorophyll A, which can help the UN and member countries identify some potential hotspots of chlorophyll, which can then potentially be looked at further through in-water testing to see if that is in fact causing eutrophication events. And so we are working with ESRI to do some mapping and subsequently user engagement with member countries. And moving forward with CEOS, what we'd really like to do is to look at some of these national and regional products to see if we can produce some more in-depth and regionally specific products for chlorophyll A. And this is what we're going to be working on with CS Coast moving forward, is this targeted capacity of national and regional monitoring of coastal eutrophication using some of the satellite capacity. And there are some efforts, such as what is being done by the Northwest Pacific Regional Seas Program, and they have been supported by JAXA, which is one of the CEOS space agencies, and a GEO, Global Earth Engine grant. And as that project develops further, we're hoping to collaborate with now PAP, JAXA, and other space agencies to see if we can build on some of their expertise in the CS pilot areas, as well as other regions, to develop regional capacity, as well as to develop new tools and indicators to bring in some of this more advanced monitoring. So incorporating monitoring across the land-sea interface to look at changes in land use related to agriculture, stream runoff, and things of that sort. So it's a really exciting time in measuring coastal eutrophication, and we look forward to the discussion. Thank you.